So let us discuss this question, assign elements to groups with constraints. Now let us dive into the first example. Here we are given with some example with elements and we are given with some groups. Now an element can be assigned to a group only if this group can be divided with this element. Let us see whether 8 is divisible by 4. Yes, it is absolutely divisible by 4. So I need to get the index of that element. So my result will be like here 0. Now I got this 4. The thing is, I got 4 and it is divisible by 4, and I also got 2. But if there are more than one elements where we can assign to a group, to this group I have more than one elements, and also for this group too. Now I need to get the smallest index. Now the smallest index is 4, or the smallest index is 0 and the element is at index 0, so it will be 0. Now for 3 I need to iterate through this all, and if I didn't get any element which can be assigned to a group, then I need to assign -1. Then I'll go for 2. I got a 2 at index 1, then I'll initialize 1 here. Then I'll go to 4 and I got a 4 at 0. That means 4 is divisible by 4. If you see clearly, a group is assigned only when this element where there is an element where this element's multiple or this element is a divisor of this group. That means 8 has some divisors of 1, 2, 4. These are the divisors of 8. So what will I do is, let us go to the next example. We are having 2, 3, 5, 7, and let us go to 3. Sorry, the first element 2. Now it is having 1 and 2. Let me search for 1 and 2. Whether do I have? No, I didn't have any 1 and 2. So I'll initialize -1 there. Now I have 3. Whether I have a 3 or the multiples, sorry, the divisors 1 and 3. I'll search for 1, I didn't get, and I've searched for 3 and I got at 1. So I'll initialize 1 here. Then I'll go to 5 and I'll go through the first element, it is 5. So I'll initialize 0 for the result at this index. Then I'll go to 7 and I didn't get any 7, or if you see I am searching for the divisor 1 and 7. Now I didn't get any divisor like that, so I'll initialize -1. If you see, I think it's clear, -1, 1, 0, -1. Yes. So the problem is not with the searching but with the time complexity, which is going n square for many people, because all are doing like whether is this 2 is divisible by this, by this, by this. Now for every n elements, and if the same is given here, then it will take n square time complexity. But before that, let us take some example. Like here, as I did, 1 and 2 are the divisors of 2. I need to get the factors of these elements. You can Google that. There are only 128 multiples, sorry, the divisors for 1e9, no, 1e5. So even for this element there are only 128 divisors. So I will store the divisors, or I will get all the divisors and search for this divisor in this elements. Now how do I search this? Before that I have 3 for 2 times. So what will I do? The first thing I'll do, like, wait a second. First thing, 3, I got 3 at index 1. Now I got 3 at index 1 and 5 at index 0. Even though I got another 3 at index 2, I don't need that. I will initialize this in an order. map. Now there is a problem that I have initialized 1, or let me say 1 is at index 3. Now what will you do? And you are having 1 and 3. So when you got 3, you need to search for 1 and also for 3. These are the indexes where you got 5, where you got 3, and where you got 1. Now you go to 1. This is the divisor of 3, and you go through this, and 3 is now will be my answer because I am going through the wrong. Now if I make this 3 as the index, so here it is my 1, here it is the index 3, but I am missing this one. This is the 3. This is the first divisor which can be divisible by 3, but I am missing this. So the first thing, I will be initializing a mini. I need to take the minimum index. So I'll initialize this minimum index to maximum, that means infinity. And after iterating this hash map, I will be using a hash map, and if I didn't find meaning. So even though after iterating through this unordered map, even then the mini is infinity, then I will initialize -1 there. So my algorithm goes like first thing, initializing unordered map. This will be like int comma int. Now go through every element in elements, iterate elements, and and there is one condition like, wait a second. So if I got 3 for the second time, I don't need to change it. So I will only change when I didn't get the element before. If element is not found in my unordered map, will be named as MP. If I didn't find the element in MP, then only I'll initialize MP of this element is I. I'll iterate elements with I. Now this is how I build the unordered map. I'll initialize the result which I need to return at the end. Now here comes the part I need to come through every element, and I need to change the result. So for every element in elements, I need to do something here. So here I'll take all the divisors by a function get divisors for the element of the current element. Now I'll store that in a vector int. Now for every divisor in divisors, I will search for this divisor in MP. Now if I am successful for searching it, I need to, if you remember, I need to get int mini is equal to int max. So this will be my minimum. Now if I have searched that, and if I have got that, mini will be updated to minimum of mini comma mb of divisor. So this is how I get the minimum for the present element. Now result of the current I will be, if the mini equal to int max, then it will be -1, else it will be mini. After that, return your result. But when you are calculating the divisors, don't forget that if you have a 8, 1, 2, 4 till here, you need to find, and 8 will be the last divisor for n. So should go through till root of n. This is how you get all the divisors. So this is how you solve this problem. If you like this video, share to your friends and subscribe to my channel. And if you have any doubts, please comment in the comment section. Thank you.